So this is not my community. I hope I can do a good job, especially after Dave's talk. So how many people here know what's information retrieval? Okay. How many people here do query analytics? Very few. This is the largest potential that you have, because in the queries you have semantics. So you have to do it. And I can point you to a great book by Lou Rosenfeld that has a lot of work on how to do query analytics. I think this is the best recommendation I can give to SEO people. So today I will talk about all the biases in search and recommender systems. I guess it's targeted to understand more what may be a black box for you, right? How search works. And I will start just telling you what I do in Intent. So Intent is a company that does a semantic search technology, white label, that includes conversational search and conversational AI. So if you need to put real search in your products, in your app, and also understand voice and be able to talk to your customers, we can help you. Okay, so let's go to the beginning. So the beginning will be, as I was afraid that not all the people knew what was information retrieval, I said let's do a short course of information retrieval so we all understand what we are talking about. And let me tell you a bit of history. I'm one of the oldest guys here, although this is even older than me. So here says, I don't know if you read this, this is one of the first papers in the relational model. So basically, what today we call databases is really relational databases, because any data is a database. And this paper is from, if you can read here, 1970. So many of you didn't exist at that time. But the interesting thing here is that if there were no databases, what was there to basically categorize this? And you can see here that the category is information retrieval. So information retrieval from the 60s, much before databases, and it started with library search. Of course, we continue with web search, and now it's every day in your mobiles. But here you have two different points of view. So because of history, databases was split in structured databases, which is relational databases and what is called databases, and information retrieval, which was search. But today they're converging. We have things like NoSQL databases, a three-column store. At the end, what we want is to store everything, structure, semi-structure, no structure. And then we need to understand what is the difference between information retrieval and data retrieval. Because data is not the same as information. So data is the raw material. Information is something that you can use to, for example, create something. And here I have a very small taxonomy where I differentiate different fields depending on the query. So if you have the query, then if you have unstructured data, that's called information retrieval. For you, it's called search. If you have a structured data, that will be called databases, but should be called really relational databases, because databases should be more broad. Now, if the query is implicit, and Don will talk about that tomorrow, if the query is the user, that's recommender systems. The context is the query. You don't have explicit query, but still the query is there. And if you don't know the query, not at all, it's data mining. You find the answer, and when you find the answer, you say, okay, why this outlier exists here? And then you get the query. Oh, I didn't thought about this, like fraud or other things. So this is the world of computer science, and these are the different research areas that we work on. Today, I will talk mainly about information retrieval and recommender systems. And if you want to ask questions in the meantime, please stop me, because I will talk about many things. And if you don't understand my accent, please also stop me. Okay, first, what is bias? If you go to Wikipedia, you will find one possible definition of bias. I will use that one. So there are three types of biases. One is the standard that you learn in statistics. If you learn about a skew distribution. So how many people here took a statistics course? Okay, more than information retrieval. That's good. So what is bias here? Bias is this. It's something that is wrong in our measurement. So the measure is fine, you get a normal distribution, but something went wrong in the experiment or went wrong in the measuring device, and we have a systematic deviation from the reference value, and we get things wrong. One problem here is which is the right reference value, and I will get back to that. For example, what should be the right percentage of women in this room? Very hard to answer. Maybe it's not 50%, but maybe it's not what we have today. Okay, cultural bias. This is our background, our education, our language, our religion. And in this room, we share most of these cultural things. And finally, we have cognitive bias. This is the most dangerous. This is you, every person. Obsessions, fears. And you can go to the web and find these things like 20. You can find 100, but 100 then you cannot read it. I don't think you can read it anyway. But one is very dangerous here. It's called confirmation bias. You read something that basically reinforces what you believe, and then you believe it. And this is the root of fake news and so on. Okay, so every human data has bias. We live thanks to bias. So here we have to look to one side of the street in London. If we don't look to the other side, we'll get killed. So we need this to survive. And then you have many cultural biases, things like gender bias, and this has been in the news many times, race bias, sexual preference, age, and so on. I will not read all the list. So these are some of them. Okay? But then you have statistical biases, things like how you gather the data. I will talk about this a little bit. Is the data valid? Was valid 6 months ago? Is complete? And so on. And then you have cognitive biases, and I will not put this 20 or 100. It's too hard, and there's no research on that. I will put just one. It's called self-selection. It's your choice. I mean, you participated in the process. You click there. You need to be aware of that. So they are biased to define bias. There is bias against bias, and they're all possible biases, right? This is part of the problem. Some people extrapolate results from social media, and they get wrong answers. For example, let's take Twitter. Twitter is gender bias. There are more men than women. It's age bias. There are more younger people than older people, although that is changing too. It's geographically biased. It's where people live. East Coast, West Coast in the US. Educational bias. Usually it's people that already went to university, and they have a good job, and they have time to use Twitter. Of course. And that means they have a good job. Economical bias. And of course, they're a bit geeky. They like technology. So these are a few of the many biases you have in a Twitter sample. So of course, what Twitter thinks is only what some influential people of this kind thinks, but it's not the whole population. A lot of people is working in this problem on analyzing what's the impact of race, gender, and other important biases in systems. However, there are other biases that will be very interesting for you that nobody talks about and affect all of us. So what I will try to do here is an attempt to do an unbiased, but personal, so it's biased, analysis of what happens in search and recommender system. So what is the impact in search and recommender system? So this is the summary. So if you can get the summary, the rest are the details. Most systems are based on implicit user feedback. Today, that's a click, right? Most of the time, a click means positive feedback. There are a lot of accidental clicks on mobiles. We need to get them out. Basically, you can use the dwell time. But at the end, if the dwell time is reasonable, every click, most of the time, means positive. And most people don't do analysis for different cases. However, that data is biased to what the system is showing us. And here is a very important thing. That's a decision of the system. So when you go to buy something in Amazon, you are clicking only on the things that they're shown to us. So the system has a lot of power on deciding where you click. And I will get back to that. So how many people know what's the filter bubble? Filter bubble, echo chambers in users. Okay, so there will be all the people will put their hand out. People that work in search need to know what is a filter bubble. So personalization creates filter bubbles, creates echo chambers. I will get back to that in the presentation, but this is a summary. But also you have the echo chamber of the system. Let's say you do a system that does so well that it's always showing the same things to the same people, and the feedback is that the people love it. But maybe it's not enough traffic. And then they don't understand why they have so much success, but not enough sales. So the system is killing itself because it's basically targeting only some people with some products and not knowing the world well. This is something I will talk at the end, is the echo chamber, not for the people, is the echo chamber for the system itself. Of course, it has to do with the people that develop that system. And then you may have things like competing teams. For example, you have a company where you have the user experience team, and every time the user experience team says, oh, we improve user experience in 10%, the monetization team says, we are losing 10% of money. What is happening? Because usually business is not correlated with user experience, right? And I hope you all know that. Can someone give me my glass of water, please? Because I get really thirsty. Okay, so this is the prologue. And then we have a very important technical question for the people that devise systems and algorithms, is what we should do when we get biased data to an algorithm. By the way, this is any algorithm in the world will get biased data. Random noise doesn't help. That doesn't do anything. So you are getting some biased data, some part of the bias is good, but some part of the bias is bad. So the question is, should be neutral? Should be fair? Most of the time, people don't ask this question, and what you get is the same bias in the output. So garbage in, garbage out, right? But in the worst case, especially if you use machine learning, you get amplified bias, which is really bad. And I guess you have read about Compass, loans, and other problems with, for example, minorities, even women, that are treated differently than, say, white men by these systems. Of course, the answer is not always you need to worry about this. But if you worry about this, because your problem affects people, every time a system affects people, you need to worry about this question. Defining what is fair is hard. And I will use this cartoon that is going around. It's a very good explanation of why to be fair is difficult. So this is the difference between equality, equity, and justice. What we want is justice. But to get justice, you need to change the system, and that takes too long. So typically what we get is equity, an affirmative action that helps to go to the direction of justice. But I'm not a sociologist or philosopher, so this is the only thing I will talk about this. But it's basically about ethics. It's ethics on the systems. So the question is, okay, not always you need to worry, but in some cases you need to worry. Now, solutions, and I will not talk about this, but you know that what people is doing. A lot of researchers are working on how to debias their input, how to tune the algorithm to handle the bias, for example, when the system is learning, or, for example, to debias the output. The easiest is to debias the input. The hardest is to tune the algorithm. And the problem of debias the output is maybe it's too late. For example, let's say you're searching in LinkedIn, and you want 50% women in your answer, and the answer is 100% men. You cannot fix it, right? Too late. But at least you need to be aware. So this is the goal of this presentation. Please be aware of all the biases that are in a system, and next time when you do something, you are thinking, oh, maybe I'm doing something wrong here. Okay, almost 3 years ago now, ACM is the largest association of computing professionals. That's like an old name, Association for Computing Machinery, but it's basically computer science, did a statement for, and this is the committee for US policies, and I'm part of the committee, the 7 properties that an algorithm should fulfill. And I will not read them, but basically here today we're talking about awareness. So the algorithm should be aware of all this. And you have things like accountability, auditability, explanation, if you have heard about explainable AI, and so on. The problem, there's no algorithm in the world that does any of this. So if insurance companies take over, developing software will be more expensive than health in the US. I hope that doesn't happen. I shouldn't say it. Maybe someone in insurance company is looking at this, right? But what is important to remember is that systems do not need to be perfect. They just need to be better than us. So when was the first person killed by a automatic car in Arizona, right? People started to worry. But really I want these cars in the road, because maybe less than 1/10 of the people that die today will die in the road because at least software doesn't drink alcohol, yeah? Doesn't sleep, doesn't get distracted, doesn't look at the mobile, and so on. So many things we do when we drive. Okay, so let's start with the set of biases, and they're everywhere. So this is the web. Of course, we'll use web search as the main example, and it's the best for you. And of course, the first problem in the web search is data bias. But I will not show you the typical ones. Of course, the main one is web spam, but you are experts at that, right? So I'm not talking about that. Yeah, so, doesn't matter if you are using a white or a black hat, you know about this. Okay? So I will not talk about this. But let me show you another example. So this is from a paper I wrote a few years ago. It's the largest study of the web of a country, the web of Spain. It's like 70 pages of statistics. So if you want to understand numbers in the web, you can go and download this paper. Also, we have a paper on several countries, like 7 different countries. And here I have exports from Spain to other countries in US dollars, and number of links from the web of Spain to other countries. Okay? Correlation is 0.8, larger than 0.8. So they are correlated. Well, there are some outliers that if we remove this, the correlation goes higher. So anyone knows what is TK, the one in the corner? TK. Anyone knows this country? .tk. No, Turkey is TR. Okay, homework. FM, that's easier. FM, anyone know .fm? Which country is this? We use it for radio, right? Well, this was one of the countries that sold to use the domain to a company. I think it was $50 million. Because, sorry? No, that's TV is Tuvalu. It's also here in the list. No, TK is Tokelau, very close to Tuvalu. They are all in the same continent. Well, FM is one of these countries that really is not a country in the domain name. They sold that. We did this for many countries. So here they have 5 countries, from the UK to Chile. More developed the country, higher the correlation. It's 0.9 in the UK. It's not only for export, but also for imports. So the economy of the world, and particularly tourism, is embedded in the links in the web. So this is an example of bias. Links are biased to the economy of the world. Let me give you an example of cultural bias. So this graph are 4 different countries and shows the size of web pages in these countries. And you can see the average here. So the average goes from 24 kilobytes in Brazil, almost the same in Greece, smaller in South Korea. I will explain that in 1 minute. Why is it smaller in South Korea? So these are cultural differences. It's smaller in South Korea because of a cultural difference. And here you have the famous power law. So how many people know what is a power law? Okay, very few. So everything in the web is a power law. You need to know that. Please check what is a power law. So if you take a power law, which is basically a very fast decaying function, if you plot it in a log-log graph, all the graphs are log-log, then you get a line. And you get here the main part of the distribution is this line, which comes because of minimal effort. You know the principle of minimal effort? George Sipp, 1930? No? Very famous American. I'm sure you have done this. We do it at school. How much we need to study to pass the course. That's the principle of minimal effort. We all the time do that. So the same happens for the web. How long will be this HTML page? Oh, when it goes outside the screen, right? We're done. However, if you do a very short HTML page, then you feel some shame. And that's why at the beginning it's different. So this is my principle of shame, this is mine. The principle of shame contrasts the principle of minimal effort. And they meet almost in the average. So people do enough to don't feel shame and do enough to pass the course. Yeah? This is cultural too. This is human behavior. And you can see this in many things. For example, this one is images in pictures. In pages. So Brazil, a bit more than 3 images. Chile, a bit more than 2. Greece, 3. Korea, 12. That's why you have less HTML pages. They prefer to fill the page with images. They love images, they love colors. That's an Asian thing. And in Spain, they don't like images. The average is almost 0. They just prefer text to read. I don't know why. Okay, language bias. This company, Language Connect, did this study that says if you take the top 1 million websites of the world, and there are similar studies, more than half is in English. I cannot argue with them what is the top 1 million websites because they don't share the 1 million, but I believe it's more or less true. If you take the most popular part of the web, half of that is in English. Is that fair? Well, we can compare with how many people speak that language. For example, English here is number 3, and it's less than 10%. But someone may say, well, not all these people have access to internet. You're right, maybe the reference value is, okay, people that have access to internet, how many speak English? This is the number. It's about 20%. Okay, still not fair. But someone will say, well, but what is important is the content of the web, not what the language we speak. Okay, fine. 27%. So still, it's like a double number on quality than content. So basically, there is a bias to quality in English, which is bad for people that don't speak English. Okay, gender bias. The worst one. This is a famous paper that was published a bit more than 2 years ago. They took a very large collection of news, and they used machine learning to find she-he analogies. This was in the news because, in particular, one of the authors was in Boston. So they found things like queen, king, mother, father. All these are fine. But almost all the others were stereotypes. For example, if he's a surgeon, she's a nurse. If he's a superstar, she's the diva. And the paper was called, if he's a computer programmer, she's a housewife. So not very good for the programmers. So the question is, I guess most journalists are men. I didn't know, I'm not from the US. So I did some research, and I found that yes, about 70% of the most famous journalists in the US are men. But I found another surprise. About 70% of the people that study journalism at college are women. So there's another more difficult problem to solve for women in news. Last example of data bias, and this comes from one of my PhD students. These are biographies of Wikipedia of women. So only women in Wikipedia. And you see that things are improving. So now we are almost like 24% of people that are alive are biographies of women. So you can say, well, this is systemic bias, just history. By the way, if you like history, you see that things started to change in 1780. French Revolution, equality. I think that's the reason. But here there's another bias that is much worse than history. Any guesses? This is one of the things that will be obvious after I say it. There's a book about that. Everything is obvious after you know it. Before it's not. Right? So anyone knows the answer? Well, the answer is that most editors in Wikipedia are men. And that bias is much worse than history. For example, in geography, one of my favorite topics is only 4%. History biographies is only 11%. And this is also has another bias because most people, most women, not most women, some women don't say the gender because it's not compulsory to say. So maybe this is like 15%, but still 50% is very far from 50%. So we need more women to write in Wikipedia. Okay, that's enough for data bias. The next bias is our bias. We as a group. I call this activity bias, and it's again the principle of minimal effort. So every time that we look at how many people is engaged with the web, less than 10% of the people will be engaged. I hope here it's like 0% because you're listening to me, but maybe not. But if you take active users, this will be a minority of the users, right? Most people just look. They don't even put like. They don't want to be involved or to other people know that they're involved. And this is very interesting because it means that very few actions are done by few people. This is the head of the distribution of engagement. And then you have a long tail of people that is doing not too many things, but is doing different things. And I hope you know what the long tail, right? Okay, that you should know. If you are working in SEO, and you need to know the long tail too. And the question, why we have a long tail, and we have the paper in Yahoo Labs in 2010 that explains that basically the long tail is the sum of all our long tails. So basically we have two states. We are doing the same as other people, or we are doing something special that only is ours, like a hobby, a problem, and so on. So now when you put all this traffic together, the long tail is basically the special things of all of us. And that's why we have a long tail. Because another explanation could be that you have normal people doing the same things, and special people, other people would say weird people, doing weird things. But it's not like that. We are all very similar. Okay. And here you have a problem, especially when you have a recommender system. Let's say someone of you working with an e-commerce site, trying to sell things. And here you have the curse of popularity. So let's say these are users and items, and I hope you are familiar with the recommender systems. But basically, you want to recommend an item for a person that is browsing an e-commerce site. And then, basically, we have, again, a long tail. So some things are sold a lot. Most things are sold little, but we hope to sell it to many, many people. So one thing to kill the effect of popularity is to use something that is called novelty. So novelty is, for example, this. 1 minus the number of ratings for item I divided by the number of users. So basically, it's a kind of inverse of normalized popularity. And you can say, OK, we solved the problem. We are done. But not really. That's a very crude approximation. And why? Because what is missing in what you're looking at, the data, is not that random. So for example, there are more things missing on the tail than on the head, because in the head you have a lot of information, very few in the tail. So basically you are doing a bias estimation, like the statistical one that I showed at the beginning. So you can improve this taking, this will be average precision at K. So this is a standard measure in information retrieval. Basically, this says how many items are relevant in the first K elements. In the case of search, will be how many answers are relevant in the first 10 answers. If you have 10 over 10, that's perfect precision. If you have 1 over 10, this is not too good, but this is good for navigational queries. And if you have 0, of course, it's really bad. So worse yet, you have the reinforcement loop. You have this feedback. You are showing things that are popular, you get clicks on things that are popular, you think these things are better, you are more popular, and then the rich get richer and the poor get poor. And we need to break this cycle, otherwise we're deceiving ourselves, we're fooling ourselves. So if you're in charge of this system, you need to be very careful to fool yourself. So, depends on the collection how this works. Here I have Movie Lens, which is a famous reviews of movies. Or for example, Trek collections. Treks are the benchmarks for search that is used by researchers. And of course, the curves are different, but basically you need to solve this. You will have the slides available. I will not have time to talk too much about this, but for example, in a work that we did with some friends 4 years ago, we showed that with 1% of the URLs, we can answer 25% of the queries. This was at Yahoo. So basically, if you knew which 1% to index, you can answer already 25% of the queries, which is a lot. And this is another power law. That's why it works like this. And I will skip this, but basically there are a lot of reference to where you can find this if you're interested in how to get rid of the popularity bias. Okay. But this activity bias, this minimal effort at work, also affects content. This work of another of my PhD students. We wanted to ask the following question. How many people produce half of the content? And you may think about this inside your organizations. How many people produce half of the content of your website, for example? Okay? And we look at 4 different data sets. The first one is a small one that was available for Facebook at the time of Katrina. And of course, it's biased to all the people that has a public profile in Facebook, which is an interesting bias, very hard to describe, but it's a bias. And there we found that 7% of the people did half of the posts. One of the main things here is that the people that is basically saying things in the web is people that want to influence other people. So this is biased to basically people that likes to talk, likes to say, is opinionated, and so on. Second data set is a large one from Amazon reviews that is being collected in Stanford from a long time. It's available. Anyone can download it. Although there was a problem with gender bias recently, and they had to take a big part of the data set. Here, if you go to movies, 4% of the people write half of the reviews in movies. When I saw this result, I told my student, please go and check your code. This is impossible. I mean, people is not all the time writing reviews. Well, 1 month after we published the paper, I don't know what happened, but Amazon started to sue fake reviewers. And this continues next year, and this year too. So for example, here is from 2019, an article saying that the problem is getting worse. Because you can buy reviews. Also the same for items. Third data set. We had access to almost all Twitter in 2009. At that time, Twitter shared this with a German institution, and we ran our algorithms inside them. So we found that 2% of the people write half of the tweets. No surprise here. It's called ego. There are some people that every morning have to tweet. I will not mention names. The last example, Wikipedia. All the data of traffic of Wikipedia is public. It's an amazing resource to know what people are looking for. 2,000 people wrote the first half of all the entries on English Wikipedia. No surprise there, they were paid at the Wikimedia Foundation, but maybe that's the reason we have Wikipedia today, because very few people, because of the principle of minimal effort, will contribute to something that is empty. At least it needs to be half full, right? If you are a positive person. Otherwise, it's half empty, you don't do it. Recently, we got results for the dynamics of this. This is unpublished, so you are one of the first people that sees this graph. For example, in Wikipedia, which is the blue line, finally, we have an increase of people contributing to entries in English. So it's not like 0.06%, maybe it's like 0.1%. But something is something. And also you see how it's going down in Facebook, in the same sample, and also in Amazon reviews is going up. So I guess this has to do with the fake review thing that are being fixed. Okay. Another thing that may be of your interest, that I was my own interested, is something I call the digital desert. How much content in the web is never seen? Anyone here knows how many websites there are? I mean, if you don't know, this is like I asked you the population of Boston and you live in Boston. You are search engine optimized, so you need to know the number of websites. Any guesses? How many? Any guess? Number of websites. Sorry? 8 billion, more than one per person in the earth. That's too much. No, that will be too much. I mean, it will be, for sure, the digital desert will be half the web. Any guesses? Number of websites, active websites. 1.7 billion. In between, it's about 200 million. It's still 200 million. So 1 every 2 people in the US. How many do you know? How many Google knows? But this is number of websites, not number of pages. The number of pages is infinite. You can go to a calendar website and you do a bad crawling, you generate the whole history of humanity, the past and the future, and you never end collecting pages for different months. So be careful. Crawling, there are many ways to trap a crawler. So we have 2 numbers here. We look at Wikipedia. We look at everything that changed and was added in 1 month of Wikipedia, and we checked the logs the next month, and 31% of that, no one saw it in 1 month. So this will be one measure of the digital desert. Could be up to 30% in a website. And we look at the Twitter data set, and we find out that 1.1% of the tweets were done by people that don't have any followers. I don't know if they understand how Twitter works. But this is like going to the Death Valley and scream. It's a cathartic experience, but no one is listening to you. Okay? Okay. Next problem. You are doing or studying search. So how many people here has a search functionality to search your own website? Okay, should be all the people. I mean, queries have semantics. Even if few people use it, the top queries will give you a lot of insight. Put search in your website. Okay, you have a search system that you need to handle, a recommender system because you work with an e-commerce company. And now you do 2 things. You sample data, right? So how many people here sample data? Queries, pages, okay, a few people, not too many. And then you do something, and you don't do it very well, and you add more bias. So when I say algorithmic bias, will be a bias that comes from the algorithm, not from the data. It's additional to the data. Your algorithm is doing something that is not good. So let me explain these 2 things. So for example, you can recommend news. And this is one country where you have different regions and news coming from different regions. And most news comes from the capital. So this will be the US too, Washington. So if you do a recommender system for news, all the people will look mainly at news from Washington. But if you're in Hawaii, you don't want to see only pictures from Washington. So what we did is a system that basically, depending on from where you are coming, you put more news that are local to you. So you de-bias the geography. And we did an experiment in the wild with a real system and real people prefer that. Prefer to see something that is close to them, and also the news that are important, but the first thing is things that are close to them. So sample size. That slide should have been earlier. I don't know why it's here. The other one, but doesn't matter. So let's say you are sampling, and maybe you know enough, you know statistics, and you use the standard interval error, which is the first curve. It's one of the classic formulas you find in sampling. But the problem with this formula is that it doesn't work with very small probabilities. So basically, something that happens very rarely, this is not a good estimator. And this is the case for click in an ad, right? 1 in 10,000, 1 in 100,000. Well, the standard formula you find in statistics books diverges for 0. Don't use it. You have to use something called aggressive cool. And sorry, this is one of the few formulas you will find in the presentation because it's very important. That fixes this problem. And you see here in the graph that basically it's not infinite for 0. And then it's much better. So let me give you an example so you understand the problem. Let's say I want to measure something that happens 10% of the time. Let's say I have something very frequent. 1 click for every 10 visitors will be very frequent in the web. And I want to measure if it's true that happens 1/10 of the time. Then using the standard formula, you get that with a really bad confidence interval and 10% relative error, you need to take 900 samples. So for example, you take 900 clicks, you look at here, and never happens, you say, no, this doesn't happen 10% of the time. Well, the only problem that this was wrong, the right estimation is 2,300, and of course, if you look at 2,300 clicks, you will see this happening, and the probability will be different from 0. So very careful, you need to have the right sample, and when you're working close to 0, don't use the statistic books, use more sophisticated things. The same happens when you sample queries. So this is a real query log. In a log graph, you will see a cell line. And here you have other samples, and when you sample too small, then you get something that is not even close to what you had. This is the problem of power loss. You get less queries in the head, and you get even more or less queries in the tail. Here it's not easy to see, because it's a log graph, but this part that looks long is much, much smaller than this one, because here it's a log graph, you have millions. So you need to be careful. So this fraction, these 6 queries here, is much, much smaller than the fraction here. So it doesn't work in the tail. So good statistical sampling in the web doesn't work for the head, doesn't work for the tail. You can fix it. I have some work on this, doing a stratified sampling. For example, here you have an example of taking 150 queries for more than 100,000, and you get exactly the same distribution. So you have the exact head, and you have a real tail. In mobiles, the number of unique queries is about 30%. In desktop, it's even larger. So if you don't do this well, you will find that the long tail is different from the reality. OK, let's go to the last part. Interaction. This is the worst part. Most people are not aware of this, and this is where I'm most worried. Because you have this algorithmic bias, and then self-selection bias. So it's the interaction between the system and you. Let's say you go to this site. I think you will recognize this site. And the first bias here is the main one. It's called presentation or exposure bias. This is very important in medicine, exposure bias. Have you been exposed to something? And this happens if you have a 3-item recommendation, you haven't been exposed to the other million that could be there. So you cannot click if something is not there. And more, you don't know what is not there. So this is the worst bias today, because that's controlled by the system, not by you. The second one is position bias. In the Western world, we are accustomed to look first to the top left corner because we read that way. In other countries, will be, for example, the top right corner. So more people look there. Moreover, more people click on the first result of a search because it's in the first position. That's called ranking bias. So people really have faith on the system. The first result must be the best, although we know that that's not true. Not always true. Another bias here is social bias. So anything you will do will be biased by what other people said, right? You look for the ones with more reviews. I look for better reviews, but also more reviews, because I know there is a review spam. So you need to look for many reviews, harder to spam. A product without a bad review is suspicious, right? At least one person didn't like it. And then you have other interaction biases. For example, how many people scroll? Anything below the scroll bar will have less clicks than things on top of the thing. And I'm sure you know all this, but many people don't know this. Okay? And one thing is that all these things are basically a cascade of biases. Some are from the system, the ones to the left, and some are yours. Some people cannot read without moving the mouse. Some people cannot be without clicking every 10 seconds, and so on. That's your self-selection, and this gets worse. Here are some results from Meditative using eye tracking. So what really people look, so in the past when there was only text, people look at the top left corner. after Google started with universal search and adding other types of answers, people look more at images and videos, and also some ads because they have images. And then you get things like this. This is a real distribution of clicks in a search engine. And of course, the number one has a huge fraction. One reason is no navigational queries, right? And someone mentioned navigational queries before. Navigational queries is, again, the principle of minimal effort, because people prefer to say FB search, click, instead of fb.com, enter. Right? Almost the same work, but they prefer to go through the search engine. Now, that's about 15% of the queries. If you take out the 15%, that's the green square, then you get the real distribution, but still, the first one has a bigger fraction because of ranking bias. And you can see here another example of interaction bias. Some engineer in the first search engine, anyone knows the first search engine? No? Okay. Why we need to have 10 results in the first page? Well, someone decided that. And then, of course, people, because of the minimal effort, don't click on the next page, and then you have less clicks on the same next page. Mobiles are fixing that with these infinite screens. That's good. But in desktop, still we have this problem. So if we have a log-log graph, and we put distribution in a log-log graph, we get this. 3 different power laws, 3 different lines, but we know it's a bias. It's unreal. So what we need is to find the real distribution. What would happen if the things were not sorted and they were random? And at Yahoo Labs, of course, we work at that for the search engine. Also, the major search engines do this. And we are the only ones that publish how to do it. And even that was a best paper award in one of the top research conferences on this. Then other people have worked on, for example, using machine learning to rank with bias. And I have been working also on fair rankings. For example, when you search for people, let's have half of the answer women. But this is in the output. And you hope you have enough women to fix the problem or to put them more close to the top. So this is an example, the first case of the bias in the input. This is an example of tuning the algorithm. And this is an example of the bias the output applied to search. OK, the last one. I would call it second-order bias. You take this and go back to the web. You go back to the web, directly to the web. Let's say you're writing a blog content, and you have here some search you did. You have a new page. You take 3 pieces of text that you like. You put it in your blog. Yeah, that's called a mashup, right? Of course, you are not doing plagiarism. So you put quotes, you put a link back to the source, and you put the name of the author. These 3 things are the difference between plagiarism and research. Only 3 things. Of course, here you feel some shame. There's nothing from you, so you put some text. And now comes the ego, and you put your name. And these are the things that people do. No? Using others' work, a bit of shame, and then a lot of ego. No? And then you publish that back in the web. What is the problem? What is the problem with this? This is not only biased to the ranking, it's biased to what that search engine thinks is good in the web. So you are reinforcing the ranking function. And this is much harder to track, because you need to find, and we did this with another PhD student, you need to find the ancestors of a page, which is very hard today when you have, say, 100 billion pages. But 10 years ago, we showed that about 35% of the web could be traced to a previous state of the web. So basically, 1/3 of the web was like a semantic repetition of other pages. Today it's worse. OK, and the last one is the feedback loop, personalization. Your data goes back to the system, the clicks, very important. And here, you have many problems. So one I already mentioned, the filter bubble. Basically, the rich getting richer or the poor are getting poorer. And there are solutions like getting out of the bubble. You saw this movie, right? You didn't read the book, but you saw the movie. At least here you understand the problem. You are happy until you know that you are in a bubble. After that, you want to get out. The good thing about correlative filtering is that breaks the bubble, because basically you get data from other people to show new things to you, because those new things are not in your data. They are new. Solutions that are used in search and recommender systems are novelty, diversity, serendipity, and one that I would like, I don't find, is my dark side. I want to see what the most different person from me is doing, not because I want to know what the person is doing, because I guess I would never do that, but I want to know how far I am from that person. Because I think today we think that people is closer to us than we think. And every election proves us wrong. So no comments on that. So a recent paper by people in Google Mind did a very interesting model on the filter bubble. And if you know about exploration algorithms, basically armed bandits, different exploration algorithms will increase the bubble. So for example, random will not increase the bubble. So random is the best, but random doesn't help too much to sell things. But things like UCB, Thompson sampling, and even the Oracle basically will increase this bubble effect on people. And now I'm working, I think I don't have more time, so I'm working on the systems. Basically, I'm interested in having fair information markets. Because if not all the sellers in a market get the fair part of the traffic, basically that business will die. If you don't get enough traffic, will die. If you don't get enough traffic because of bad quality, that's fine. But because you don't get the traffic because the system doesn't show you because they don't know how to do things well, that's a problem. Okay, to finish. Here is one possible classification of all the things I have mentioned in these three things, statistical, cultural, and cognitive. So it looks like everything that's related to you is mainly cultural and cognitive. What about the rest? I have 2 question marks there. For example, if we ask a group of women to do a recommender system, and we ask a group of men to do the same recommender system, will those systems be the same? I think one will be more fair than the other. Okay, so this will be a good experiment. No one has done this experiment yet, but there was a very similar experiment done in the Center of Open Science in Virginia about 4 years ago. This is a free report, and a very interesting 70-page report of this experiment. They gave a lot of people, data analysts, all the information about the Champions League. The Champions League, for the people who don't know, is the major soccer tournament of clubs in Europe and in the world. And the question was, when people get a red card is you get out of the game, if there is racism there or not. Basically, there is gender bias on soccer, yes or no? And this was the result, sorry, the result that doesn't appear, I don't know why. 29 teams participated on this. They had 2 or 3 people. 20 teams said, yes, there is race bias. 9 said, we cannot prove it. But the most interesting thing for me is that no team did the same. So the same problem, 29 different solutions, 29 different confidence intervals, if you know a bit about the statistics, and only 20 could prove that the statistics were about this hypothesis line. So next time you need to do something important, ask many teams to do it. They will come with different solutions, and then you ask them, give one single system, and that will be a consensus of the best you can do with this team. For sure, that will not be the best solution. Oh, here it's too late. I had to that before. Okay. So what we can do, this is to finish. So for the data scientists here, in data, we can analyze for known biases and maybe check with 20 different samples if you have other biases that you are not aware of. These could be important. Recollect more data in the hard parts of the problem where the complex is difficult, the problem is difficult, not where the problem is easy. These are, especially for machine learning, you will have better training data. Delete attributes that are associated to gender, race, or whatever. However, the truth is, even if you do that, you will not delete all bias. It's a very interesting paper of analysis of bias in New York. The only demographic data that they gave to the model was the age of the person. the system was more biased than the judges. But the good news, it was better than the judges. So a system can be biased, but can be more fair. So this is not always the same. Interaction. Make sure that you know what you are doing in your user interface. You are biasing the people depending on where you put things, on the things you show, and so on. More control to the user, that's very important. And then when you are designing and implementing, you need to let the users, the final users, to contest every step of the process, not at the end. The assumptions, the design, the prototype, and so on. Because otherwise you will find the problem when it's too late and you need to do all again. So like the question in the panel, you don't want to fail at the end, you want to fail in the way, right? And the last one, evaluation. Do not fool yourself. Oh, we increased 10%. But then it's trivial because you are basically putting some wrong evaluation measure in the wrong number of people. Okay, be aware of your own biases. Try to break this vicious cycle. You can do it. If you want to write the blog, write everything. Don't copy. And so on. So questions? There was a question
hand over there. Yep, here we come.
So my question is, if the goal is to create results that are closer to justice as opposed to equality, things like that, what recommendations would you have to designing a search results page that can kind of, it's hard to describe it, remove some of the technical biases that are implicit in results and design that we currently see in Google? I hope that made sense.
Yes, but the recommendation is for you or for Google?
So I work on site search. So I design my own search.
Okay, but you are using another tool from another person to do the search, right? Elasticsearch or Solar? Solar, okay. So if you're doing your own search, then the answer is not only about relevance. So typically we worry about relevance. This is very good, but then you need to think from where these documents are coming. For example, let's say you have a website. Is the share of every part of your organization fair on these results? Let's say, no, but in some cases it should be unfair. But the question is what you want? It's like you do a search and only say one department of your company appears? Or you should also would like to have like 20% of other departments just in case the person is looking for something else. This is the frame, the mindset. Think on the other side. So if you say, no, all my company should be represented in web search results, then if you do analysis of all the answers from your search for, say, for a month, you can say, okay, how many were clicked from each part? Why? Because of bad quality or because of bad representation? Of course, we can worry about bad quality, but most of the time, the problem is bad representation, and no one is looking at that. So try to represent things fairly, independent of quality. Of course, if you have bad quality, you don't want to represent that. But let's assume you have a good quality all over your website. You want to show everything, not to expose something. Also because if you don't show everything, you're losing customers. You are losing opportunities. For example, let's say I have a product that will be very good for 1% of the people, but when I explore that product, I never show it to a person from that group. I think the product is really bad. But if I show it to 2 people from that group, all of them will click. And then you find a niche, a market niche for that product, for that people. But you need to do a focus exploration. You need to basically use similar users to find the right users to show that. So crude A/B testing, like random A/B testing, will not find these things. You need to do much better than that. So it will be like focus A/B testing. I don't know how many people work on that. I haven't seen many papers on that. But you need to focus things if you want to find these golden treasures that you have hidden, like data mining.
questions you have. And let's give a huge round of applause to Ricardo for an amazing presentation.